IoT devices. You'll always see these scare stories about people's cameras suddenly becoming online because people haven't changed their default security. You know, people set up a camera and they just leave it as the default username and password to get in there. So if they're basically leaving it open. Because these username and passwords are just available on the manufacturer's help site. You've got your camera, it's typically something like username, admin, password, admin pass, or something like that. There's only a small combination of them. Or you just go to the camera website, they'll tell you what it is. So you really need to change the security of your IoT device, because otherwise these things start getting round and start connecting into your camera. And also, don't forget, your camera, or your fridge or whatever, potentially connected to your inner network. So if it can gain control of your camera and inject some code onto that camera, it can then talk to other devices around your house. So you've got to be careful about the security of your actual IoT devices. It's a big problem. It's going over into the security problem as well to it. One of the solutions here, there's an example here of something called fleet management in the farming industry. It's a German company that put this together. They've got a variety of devices dotted around for harvesting, transport and processing, that sort of thing of things. They've all got a different way of identifying themselves. Now this is going away from IP addressing. Like a particular grain chopper, picker up or whatever, might have a serial number. Somebody else has got some sort of bus ID or a license plate to it. Like your car's got a license plate number. You've got a national insurance number. Your phone's got a telephone number. All these devices seem to have their own little way of identifying themselves, but they're all in different namespaces, they're all in different domains to work with. But working on that, we might have a scenario where one machine needs to communicate with another machine. So they're saying it may be that the harvester needs to communicate with the lorry to be in one place at the same time in order to pick up that grain. So the harvester needs to communicate with the truck to tell them where to take the crop. And the truck just says, I need a connection with that harvester over there in this field for this particular farming campaign. Don't know its address. I don't know where it is. I don't even know how to talk to it. How do I find it to sort of get there? Now, it's fine if you know its DNS number. It's rather like saying, I want to just talk to Tony there on his phone. And I know where he is, but I don't know his telephone number. But one thing I do know is that I think he's in lecture room 3. He's in the 5th row back. He's 5 seats over. He's wearing a black T-shirt. That will be enough to identify him. I've identified where he is through a different sort of means to actually sort of get there, to be able to communicate without the need for the telephone number. So you can pick up things like characteristics, where it's who uses it, who uses this for shipping, who sold it, who's it owned by. All these objects have got different things about them. They've got different characteristics and they can form sort of relationships. Now there's already some way of locating things like that in existence. That's exactly what Google does. When you do a search, the more detail you can get, Google's search engines tie together. Like if you wanted to find out a research paper by Bill Smith on the Internet of Things that was published in 1976, then you can put in certain key phrases into Google and hopefully you get a list of possibilities of where to sort of get hold of that. So we can fit together some characteristics and have some sort of location system built on that. There's sufficient knowledge of the relationship that, okay, the thing currently knows where it is, who's driving it, which campaign it's based upon, who sold it, who owns it, who manufactured it, a lot of sort of detail around it. Then I can create some sort of entity based on that, and it just becomes a database search. You've got to find if I can somehow have an object and have a relationship with another entity, manufactured by and serial numbers and the things like that, we can put together a graph and then subdivide this into different sort of levels of attributes, who manufactures something, working down, and by everything will appear in this graph in a certain place, and it just becomes a matter of searching the graph. Now this is a bit outside our range for, say, the Internet of Things. It's something that's very much on the database, data science area, big data. They are used to solving these sorts of types of problems about finding things in a huge mass of data, rather than just sort of where you haven't got a key field to look some of these things up by. So you can have a range of attributes, if you like, a circular sort of hierarchy structure, and then something will fit into that in a sort of nice way. The more you can narrow it down, if I can say, look, this particular tractor is manufactured by Ford, okay, well that narrows it down to a certain set of people. Like if I can say, well, I can say to an outside person coming in here, I want you to get hold of that guy and bring him out and force him to buy me a drink or something like that. And I can say, well, they're just in here. Well, that limits it down out to the entire university. At least you've got the right room. I've got a choice of about sort of 80 people in here who might buy me a drink. But if I then say, okay, yeah, he's in that room, and they're on the 5th row. So everybody on the 5th row, well, that's narrowed it down. Nobody else doesn't have to buy me a drink just yet. And they're wearing a black T-shirt. Okay, how many people on the 5th row are wearing a black? Eventually, you'll have enough characteristics, T-shirt colour, role name, room name, all these different characteristics. The more specific you can get, the closer you are to identifying that particular object that you want. The higher the precision of each attribute, the easier it is to get it. Now this next diagram starts getting a bit sort of complicated. This is a sort of structure, if you like, that a database is trying to work through. A graph structure to be able to find specific devices with specific attributes, and you're representing them in a certain way. Now this is what the searching people have to deal with. This is where a lot of the Google research is sort of working on. So they have to take representations of this data, a harvester manufactured by class who's got a name, relationship, entity, or two things going between two entities, so where they are. The more of these things that we can sort of have, and the more of those facts we can put in this sort of graph database, we can more easily find out what that particular device is, where it is, how to contact it. So it's just what presenting there is just an alternative to saying, oh, just give them an ID number. Just the ID number doesn't tell you anything about that particular object. Whereas if you can work through a series of relationships, it's trickier to do, but you get a lot more out of it. A lot more sort of useful information in sort of getting there, and related information that you can sort of get it out. So how do you find a thing? You just say, okay, once these things are stored in the database, the truck just asks the database, I'm looking for a device that's manufactured by class, driven by Farmer Tom, owned by Farmer Tom, driven by Ingo, so it can identify something. That's like a Google search. Like that you're sort of doing, and that's what Google's doing in the background. That's why they're so good at it, at finding things, to resolve things out, finding where things are, finding nearby objects as well. So it doesn't just sort of give you the ability to get one object talking to another one, but also to find things in the immediate vicinity, things that are related to it, things that are on Tony's row. People that are in Tony's class, people that are in Tony's family. Sorry, Tony, I didn't know this group here. So you can find related attributes to them, whereas just knowing the telephone number or the DNS number doesn't really give you enough to it. So it's a kind of search engine. A kind of search engine with sort of incorporating the location in it in the end for it. The classic search engine, you've got web crawling going on, Google's going out collecting all these web addresses, storing all those, trying to classify the pages, who owns it. That information is not necessarily controlled by the owner of the website. These web bots are just going around grabbing web page addresses. Whereas this approach, built up on it, you get a bit more better quality of information being in there. A lot easier to get a bit more extra information on what that device actually is about. So these aren't things that are necessarily in place, no. They're just suggestions of what people are trying. So if you're thinking about going into a bit of either researching these fields or looking at things in your project that's related to this, bear this sort of thing in mind. They're not very widely used, for sure, as yet. Second quick problem. How do devices communicate with each other? Yeah, communicates over the internet typically. It's not necessarily a question of finding in this case, but the different communication methods. Every device communicates independently with the cloud. They've all got their own way of communicating, and hopefully that's coming out in that assignment part about you drawing up little sort of diagrams